We are going to talk about something called random variables. And we have to be careful because even though we are going to use the word variable or variables, this is not the same variable that we use in algebra. So we are not talking about the variable x or the variable y that represents a specific number. So what is really a random variable? A random variable is actually a set of values or a subset of real numbers where each element of the set has an associated probability. So take note, when I speak of random variable, I don't mean a specific number. What I mean is a set of values. And because it is a set, it is usually represented by an uppercase letter. Sometimes I use the letter A or the letter B, but most books use the letter X to represent the set that we are talking about, the set that we call as random variable. And take note, every element of this set has a probability. Now, to show the probability and the values of the random variable, we use a table or we use a formula. This table or formula is called the probability distribution of the random variable. So let's have an example to show how a probability distribution is going to be constructed. Here's our example number one. A multiple choice test is composed of two questions only. Each question has four answer choices in which only one is correct. Let C be a random variable whose values are the number of the correct answer in the said test. Construct the probability distribution of C. So take note that in this problem, we are asked to construct a probability distribution and the random variable is represented by capital letter C. Now this set C is composed of elements which are actually the number of correct answer in the test. There are only two questions in the test and it's a multiple choice test. Every question has four answer choices and among the four only one is correct. Again, one more time, the letter C is the random variable and the elements of set C is composed of possible number of correct answer in this test. So here is the probability distribution table for the random variable C. It is composed of two columns. The left side columns are to be populated by the values of the random variable C, and the right side column, of course, are the probability for each of those values. Also remember that C is the number of possible correct answers. There are only two questions in the test. So if you are going to take this test, for example, is it possible for you to have five correct answers? Well, of course, no. There are only two questions in the test. You cannot have five correct answers. Is it possible for you to have only one correct answer? It is very possible. That will happen if you are correct in number one, but you are wrong in number two. And it can also happen if you are wrong in number one, but correct in number two. So you can have one correct answer. Is it possible for you to have two correct answers? That's also very possible if you are correct in number one and correct in number two. But you can also have zero correct answer. That will happen, of course, if you are wrong in number one and at the same time wrong in number two. So therefore, the values for the random variable C are 0, 1, and 2. Now we are going to compute for the probability of these values. For example, what is the probability of having zero correct answer? That is the same thing as saying what is the probability of being wrong in number one and wrong also in number two. Same thing, we are going to find also the probability for 1 as well as the probability for 2. In order for us to correctly compute these probabilities, let us look at the actual results if you are going to take this test. Now, suppose we are going to label the answer choices. Here I'm going to use letter C for the correct answer, and I will use W's for the wrong answer choices, and there are three of them. So I label them as W1, W2, and W3. Let's pretend that we are actually going to answer the test. So here's number one and number two, and we are going to pick one of the four choices for number one and again another choice for number two. So for example, if we happen to pick W2 as our answer to number one and C for number two, that means we have a wrong answer to number one, but we have the correct answer to number two. We could have also chosen W3 for number one and W1 for number two, which means it's wrong answer for number one and it's also a wrong answer to number two. or maybe we have chosen the correct answer to number 1 and also the correct answer to number 2. We can continue this, and possibly another case is we have W2 for number 1 and W3 for number 2, and so on and so forth. So now the question is, if we are going to continue this, how many different set of answers are there? We can answer the question how many different set of answers by applying the fundamental principle of counting. There are 4 answer choices to number 1, and there are also 4 answer choices to number 2. And so therefore, the number of different set of answers can be found by multiplying 4 times 4, and that will give us 16. There are only 16 different set of answers. Since 16 is not really a huge number, we can actually write all of the 16 sets of the answers, and then we can figure out how many among the 16 shows 1 correct answer or 2 correct answers or 0 correct answers. So here I'm going to show you the 16 different set of answers. For example, I have here correct in number 1 and correct in number 2. I can also have correct in number 1 and wrong in number 2, and it's wrong because it uses W1. I can also have the same case correct in number 1 but W2 in number 2. So it's not the same case as the first one, because in this case number 2 is choosing W2. I can also have correct for number 1, wrong in number 2 but using W3. Another case is number 2 is correct, wrong in number 1 but using W1. Wrong in number 1 using W2 but correct in number 2. W3 in number 1, correct in number 2. I can also have another case where I have W1 for number 1 and W1 as well for number 2. W1 for number 1, W2 for number 2, and W1 for number 1, W3 for number 2, and so on and so forth. I hope you can see that I can have W2 for number 1, W1 for number 2, and so on. So these are the 16 different scenarios or 16 different sets of answers. As you can see, this 16 can be divided into 3 groups. The first group on the left side shows that you have 2 correct answers, or I have 2 correct answers. I got number 1 as correct, number 2 is also correct. And as you can see, this is only one among the 16. Only one situations where I have 2 correct answers, 1 out of 16. The other case is the second one here, where you have 1 correct answer, and that is happening either in number 1 only or in number 2 only, and there are 6 of them, 6 out of 16. And of course, the last one where you have 0 correct answer, number 1 is wrong and number 2 is also wrong, and there are 9 of them, so 9 over 16. So these fractions, 9 over 16, 6 over 16, and 1 over 16 will become the probabilities in our probability distribution table. Let's look at now our probability distribution table and input these numbers. So here we have again our probability distribution. The probability of getting a 0, meaning no correct answer, is 9 over 16. The probability of having 1 correct answer is 6 over 16. And the probability of having 2 correct answers is 1 over 16. Now, you may say that the way we solve the problem is quite tedious and possibly time-consuming, most especially if the numbers involved are bigger. Say, for example, if there are 3 or 4 or 5 questions in the test. We are going to redo the problem now. But keep in mind that the probability of choosing the correct answer in each question is 1/4, and the probability of choosing the wrong answer is 3/4, because among the 4 choices, there's only 1 correct answer. Now let us consider the case where you have 0 correct answer, which means that we have wrong answer to number 1 and we have also a wrong answer in number 2. The probability of getting the wrong answer in number 1 is 3/4, and the probability of being wrong in number 2 is also 3/4. Now also keep in mind that the answer in number 1 is independent of the answer in number 2. And because these two events are independent, we can actually multiply their probabilities. That means we can multiply 3/4 times 3/4. And we are going to get 9 over 16. So the probability of being wrong in number 1 and wrong in number 2 is 9 over 16. So that's also the probability of having zero correct answer. Now let us look at the case where we have two correct answers. And two correct answers means that we are correct in number 1 and we are also correct in number 2. The probability of being correct in number 1 is 1/4 and the probability of being correct in number 2 is also 1/4. We can multiply these two probabilities together and we are going to get 1 over 16. So the probability of having two correct answers is 1 over 16. Now let's look at the situation where we have exactly one correct answer. Having one correct answer can be divided into two cases. Case 1 is when we have correct answer in number 1 but we have wrong answer in number 2. Another case is when we have wrong answer in number 1 but correct answer in number 2. But we are going to look at these two cases separately. The probability of being correct in number 1 is 1/4 and the probability of being wrong in number 2 is 3/4. Then we multiply these two together and we get 3 over 16. So this is our case 1. For case 2, like I said, you can have wrong in number 1 but correct in number 2. The probability of being wrong is 3/4 and the probability of being correct is 1/4. So we can multiply these together and we get the same number, 3 over 16. So these two cases covers the situation where we have exactly one correct answer. So therefore, we have to add 3 over 16 plus 3 over 16. Together, that will give us 6 over 16. So this is the probability of having exactly one correct answer. So altogether, we already have found the probabilities of each of the values of our random variable. So as you can see, this is a lot shorter than writing out all the 16 different scenarios in answering the test. Here's our example number 2. A class is composed of 5 students, 3 of whom are girls. 3 students are to be selected randomly to represent the class in a meeting. Let G be a random variable whose values are the number of girls selected as representative of the class. Construct a probability distribution for the random variable G. So we have 5 students, 3 girls, and 2 boys. 3 students will be selected from these 5 students as representative of the class. The random variable G is a random variable that represents the number of girls that can be selected as representative of the class. Let us construct a probability distribution for the random variable G. The random variable G is the possible number of girls that will be selected as representative of the class. Only 3 girls are in the class, and 3 students also are to be selected. Since there are 5 students in all in the class, 3 are girls and there are only 2 boys. If we are going to select 3 students, it's not possible that they are to be composed of all boys because there are only 2 boys in the class. Therefore, the representative of the class should have at least 1 girl. So it's very possible to have 1 girl and 2 boys as representative of the class. So one possible value for G therefore is 1. It's also possible that the representative of the class will have 2 girls, in other words, 2 girls and a boy. It's also very possible that the 3 representatives of the class is composed of all 3 girls. So these are the 3 possible values for G. We are now going to compute for the probability of each of these values. Suppose I'm going to represent one of the girl as G1 and the other girl as G2 and G3. The boys are B1 and B2. Suppose we are going to select 3 of these students, so I can possibly have a group that is composed of G3, G2, and B1, and this is the representative of the class. I can also have B1, G2, and B2. If I have B1, G2, and B2, then I cannot have B2, G2, and B1 anymore because that's exactly the same representative of the class. Therefore, if I'm going to continue this, I will have different possible combinations of representatives composed of 3 students only. So now the question is how many possible representatives, groups of representatives I can have from these 5 students. If you recall, we can answer that question by using combination because we are actually choosing 3 students as representative of the class that is composed of 5 students. So we have to find, or rather use, the combination formula. I hope you remember the combination formula for 5 combination 3. Here's again our combination formula. N combination R is n factorial divided by n times the quantity n minus r factorial. Our n, of course, is 5 and our r is 3. So we are going to compute for 5 combination 3. So we are going to say 5 factorial divided by 3 factorial times 2 factorial. If you are going to compute this, your final answer should be 10. There are only 10 possible combinations of 3 students coming from 5 students. Now, since the number 10 is really not huge, I'm going to write here all the possible combinations of 5 students taken 3 at a time. I'm going to use G1, G2, and G3 for the girls and B1, B2 for the boys. One possible combination is composed of G1, B1, and B2. As you can see, it has only one girl and the other two are boys. I can also have G2, B1, B2, and just like before, it has one girl, but this time it's the girl G2. I can also have G3, B1, and B2. This time, one girl, but it's G3. I can also have two girls. I have G1, G2, and then B1. I can also have two girls, but composed of G1 and G3, and the boy is still B1. I can also have G2, G3, and then B1. Another situation is G1, G2, but this time the boy is B2. I can also have G1, G3, B2, and I have G2, G3, and B2. Finally, I can also have a group that is composed of all girls, G1, G2, and G3. As you can see, I have here 10 possible combinations coming from 5 students, taken 3 at a time. And we can divide them into 3 groups. The first group at the left side is the group where you have only one girl in every combination. And there are only 3 situations out of 10. So the probability of having one girl is 1 over 10, or rather 3 over 10. Now, the second group at the center is composed of 2 girls in every combination, and there are 6 cases. So therefore, the probability of having 2 girls is 6 out of 10. And finally, the probability of having all 3 girls in the group is 1 over 10. So these are the probabilities that we are going to use to populate our probability distribution table. So the probability once more for 1 is 3 over 10. The probability for 2 is 6 over 10. And the probability for 3 is 1 over 10. You may say that listing all the possible combinations is very tedious. So we are going to redo this problem without listing those probable combinations. And we are going to come up with exactly the same answer, but in a completely different way. Suppose we are going to find the probability for 1. And by 1, we mean 1 girl and 2 boys. This 1 girl is selected from the 3 girls. And of course, the 2 boys is selected from 2 boys as well. So for the girl, we can say 3 girls select 1. For the boys, we are going to say from 2 boys, we select 2. And then we are going to compute these combinations and then we are going to multiply them. For 3 combination 1, we are going to get 3, and for 2 combination 2, we get 1. We multiply them and we get 3. That means 3 out of 10. So the probability for 1 is 3 over 10. Now for 2 girls, we mean 2 girls and 1 boy because there has to be 3 in the representatives. So therefore we have 2 girls and 1 boy. We are going to select the 2 girls coming from 3 girls. So we are going to say 3 combination 2. And of course, the 1 boy is selected from the 2 boys. So we are going to say 2 combination 1. We are going to multiply the results of these 2 together. So 3 combination 2 will give you a 3 and 2 combination 1 will give you a 2. 3 times 2 will give you a 6. Therefore, the probability of having 2 girls from the representatives is actually 6 out of 10. And finally, we have 3 girls. And if you have 3 girls, of course, you have 0 boy. So the 3 girls is 3 coming from the 3 girls and 0 coming from the 2 boys. 3 combination 3 will give you 1, and 2 combination 0 will also give you a 1. So we have 1 times 1 will give you a 1, and therefore the probability for 3 is 1 over 10. So this is the way to populate the probability model without actually writing each of the possible combinations of 5 students taken 3 at a time. So I hope these two examples gives you a better understanding of probability distribution and how they are going to be computed. These two examples are examples of something called discrete probability model or discrete probability distribution. We will go to continuous random variable next week, but for now we are going to continue practicing in constructing probability model or probability distribution for discrete random variables. Thank you.